Boom. Boom. It's 10 after. Anyone see Tony? Yeah, I just asked. Will anyone seen Tony? Can you sweep the bar and see if he's under a table somewhere? Or? Okay, he had another working group he was in? All right, excellent.
We've been waiting for you.
Yeah, we were working for you on your future.
So you asked for a 1 hour slot and then you show up late? You're killing us.
I'm solving all the hard problems. You just did You're just basking in the glory.
Hey, no pictures or didn't happen. I didn't hear a thing about hard problems you were after. Welcome. You're in the brewery. If you're not in the right place, stick around. You'll have fun anyway. It's the beer working group meeting, 99. Before we start, can I have someone volunteer to take minutes before I assign someone to take minutes? And I've done it. Yeah, it's all those hands going up. At least they're making eye contact. Usually they're going down to your keyboard, pretend like you don't hear me. It did get quiet, though. That was good.
No, both hands.
Minutes. I saw both hands were up. We have a volunteer. We saw that. Everyone saw that, right? You saw it? You saw it? Come on. Oh, okay. Good. This is your last chance to do it.
We promised them glory, man.
Don't take the microphones off. Seriously.
What did the peanut gallery say?
Figgy pudding. I don't know. What did he say? It was something in British.
Peanut gallery.
Peanut gallery. Anyone? Come on. Come on, Jeff. You'd love to do it. You can't really? Oh, wow. You got cover. No, you're presenting. You're presenting twice. That's not right. Volunteers. Come on, someone. Hey, Pierre. Perfect. That's perfect. That's just what we need. You're hired. I'll do it for you in your next working group. Yeah, see, I usually tit for tat. Exactly. Can you do it? We need you. All right. Thank you very much. All right. Jabber Scribe. We have one person on Jabber. We can respond to guests here if he comes up. Unless someone's going to be on it. Any hands? You're on it? Oh, excellent. We have a volunteer. Thank you, Tim. Yes, there's one person on it.
I'll ask questions about Jabber.
Perfect. Thank you.
Thanks so much.
All right.
Sticker for you. Actually, we ran out.
Note well. I'm pushing fast here because we only have an hour, and I like putting time at the end for discussion because we have items to discuss, even if it's just kind of updates. So I carved some of the times off that you guys were asking for because someone asked for an hour time slot instead of the 2 we normally fill.
And you didn't even want to come.
There we go. Note well. Noted well, please. This is a new note well. Please take note. Noted? Noted well? Excellent. All right. This is the current agenda. Some of the names kind of flipped. I think we got everyone represented here. And we're going to give a status update at the end. Anything missing? Let's march on. Okay, so first we have PIM tunneling, PIM stitching.
What about status stuff?
Status is at the end.
All right.
It'll give us time to discuss. Okay, I got to find it. Hang on, bear with me.
I sent you something.
Yeah, it's your old talk. Oh, that mic, yeah, stay in there. Let me get this running for you.
Yeah.
We eject people. You see the big red box, right? No.
All right. Stay inside the box.
Inside the box. Perfect. Perfect. Human bit goalie Nokia. I'm here to talk about, first of all, I'm first time, well, I've been here a couple of times, but I'm new here. Take it easy on me. No initiation procedures, please. So I'm here to talk about draft beer tunneling. We changed the name of the slides to PIM stitching because it was creating some confusion. Some great comments came up. Thank you very much. If we can go to the next slide. So let's talk about the problem, what we are trying to solve here. The problem is threefold. Number one, we are seeing some providers that they're trying to go to the next generation core. This next generation is a converged core, is a lean core. And what I mean by converged core is that previously from core point of view, there was a fixed core for business services, verticals, and fixed type of services, and then there was a wireless core. Now, as you guys have been hearing about 5G, 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 these wireless cores, there's a need for data centers, there's a need for cloud services, caching points. So from some of these providers, it makes complete sense to converge their core, to converge their services, to actually start saving money and operational status, I guess. So they want this core to be clean, meaning that they don't want to have any multicast states, they don't want to have any BGP protocol, single protocol that does unicast and multicast. Now that takes us to the second problem. The problem becomes as soon as you converge the core and you put a mobile backhaul over a core, the access network becomes very large. Let me give you an example. Some of these providers, wireless providers, they have in excess of tens of thousands radio towers. Each radio tower in the LTE network has a router, cell-side router. Each one of those cell-side router is going to be a multicast leaf. So multicast had to branch out to tens, even maybe more, 10,000 or more of leaves. So scalability is the next issue. Last but not least is when you start converging the core, the access network engineering unit and the business units are different than the core. So they want an evolutionary path to start deploying BIER. As it happens, it starts from the core, and they want eventually to go to the access. So this is not going to be a greenfield deployment of BIER. We need to have some kind of marriage between the legacy multicast services, whether it's in the GRT, whether it's in MVPN, to a core of BIER. And this is a lean, clean core, as I keep saying over and over again, meaning that they want a single protocol for MPLS and for unicast and multicast. If you can go to the next slide. So next one, please. So this is what we suggest from a solution point of view. So what we're doing from solution point of view is there's going to be two pieces to it. There's going to be signaling and there's going to be data path. Actually, this is not my latest slide, but from data path point of view, there is no changes whatsoever. Multicast packet comes to the BIER core forwards it to the other BIER edge router. When it comes from signaling, that's where we're introducing the changes. From signaling point of view, in the BIER core, it needs to be very simple signaling. So this will create a PIM domain and a BIER domain. The edge router that connects the BIER to the PIM, on one end, it's doing PIM neighboring, PIM DR joins, it's complete PIM negotiation. But when it goes toward the core, it needs to grab that SG and somehow signal it to the other BIER edge router. That signaling we could have done via a sub TLV. We are not trying to create a PIM adjacency through a BIER core. It's going to be too complex for these core providers. They just want simple SG join and prune through their core. So basically, we will terminate the PIM adjacency when it goes through the BIER. If it figures out that the source is sitting on the other side of the BIER domain, we will terminate the BIER. We need to signal the SG somehow. And as it happened right now, we use a PIM join or a PIM prune to signal that SG to the other core. So that's the signaling point, and that brings up a couple of terms here that we are willing to change if it's confusing. That brings up the PIM BFER and the PIM BFIR. Basically what these are the edge routers that terminate the PIM toward the BIER core. Next slide, please. So here's an example. In this example, as you can see, one thing before I go through the example, this solution will work for multicast data. It's not really a MVPN solution, or it's not really a GRT solution. It just in multicast in general. It just so happens that some of the MVPN multicast, as you guys know better than I do, like Draft Rawson, use PIM for signaling of the provider tunnel from one end to the other end. So here's an example. So in this example, the PE is on the edge where, let's say that the cell-side routers are sitting. They are trying to provider PIM join. They go to the PIM edge routers. The PIM signaling will become terminate. You try to get that SG somehow through the core beer to the other beer edge router, and the other beer edge router will remove the beer header from the PIM packet and will create a new PIM join, whether it's the same packet or not, doesn't matter, and it will send it all the way to the source. One thing that the PIM edge router, the one that is egress PIM edge router, needs to do is it needs to track which one of the PIM BF-IRs is sending the group, and it needs to keep track of the ID of that beer router. In that case, when it comes to the data path, you have a mapping of which PIM BF-IR is actually interested into that group, and you can multicast through a PIM core. Next slide, please. One more, please. So here's an example of the data path. As you can see, we have a table at the bottom that says lookup G3 BFER. That's our kind of implementation. So we are keeping track of all the groups and which one of the PIM BFIR that are interested in that group. So when the source gets the join, it starts sending the multicast PDUs to the beer edge routers. The beer edge routers, they're tracking which group is interested with which BFIR router, and they put the beer header. They send the packet toward the beer core. The other edge router removes the beer header and just simply forwards the multicast packet toward the leaf. Next pack.
Good. Can I ask just a question for clarification?
Sure.
This is non-chair Greg Francisco. The bit assignments, are they all the way out to the PEs, or does the beer domain stop at the P2, P1, P3, P4?
So the beer domain stops in this example at P1, P3, P4, P2.
Okay, so that the bit assignments are on the leaves of the lean core.
Yeah, again, sorry, this is not the latest updates, but you're absolutely correct.
Yeah,
so
okay.
between the PE1 and P1, P3 in this picture,
yeah,
that's the PIM domain. Between P1, P2, that's the beer domain. Between P2 and PE3 is the PIM domain again.
So the mapping there of the SG in the upper right-hand corner says PE1 for group 1. Really, it's P1 for group 1 is the destination, right? That's the bit that gets set, not PE1.
Yes, correct.
Okay.
Okay.
That's correct.
All right. So that means between the PEs and the P routers, we're going just IP multicast UDP joins. All right. Got it.
You got it. Thank you.
Thomas Eckert.
Sure.
What's the unicast routing between the left and the right access?
It could be anything. It could be or between the access and the between the PE1 and P. P1
No,
it could be
PE1
anything.
and
It could be IGP, BGP.
No, PE1 to PE3.
So in this example, we are using draft Rosen as an example. So for AD, it's BGP. But for provider tunnel signaling, we are using PIM.
So there are verbs in the PEs.
Yeah.
Okay.
And the PIM join, is there a verb context in the PIM join so it knows which one it came from?
It's not the C signal, you get the P signal already. So by the time you're hitting the P, yeah, you're gonna, in this particular example, you're gonna be calculating the P signal. Yes.
Okay, then how does the PE know which verb that came from?
You have the translation, C to P, right? You have the group translation.
Do you? Okay. Okay.
So
right.
I'm totally not understanding what's missing, right? If I'm using draft Rosen, right,
Yeah.
or the same signaling in BGP, I've got my PIM overlay or BGP overlay PE to PE signaling, where the upstream knows every downstream receiver, right? Okay, so in early draft Rosen you couldn't do explicit tracking, but you just need to do explicit tracking. Et voila, you have the information on the ingress on the BFIR. So what's missing?
Yeah. Right.
Yeah.
No, but I mean that's what the overlay signaling already does, right? In MVPN.
Maybe I can cut in once.
Yeah.
Just forget about MVP here.
Yeah. Name?
But I
Name?
mean, even if it's
Jeffrey.
not MVPN,
Jeffrey,
right?
name.
Jeffrey from
No, I mean, I don't need MVPN. I'm just saying that if I have the overlay signaling from the egress PE to the ingress PE, right, I have on the ingress PE the list of egress PEs that want to have an S, G, and that means I can build my beer tree. So I'm trying to understand what we're missing.
Beer doesn't have trees. What do you mean?
Oh, okay, sorry. Whatever the right term is, right? The beer bit string, right?
Oh, the mask. The
Yeah,
ingress
the
mask. Okay.
right? So I don't know what's missing, what we need to do new here.
Well, the new thing is that on the PE1 or PE3, you need to actually keep track of what groups are interested in that, what beer edge routers are interested in that group, because otherwise you're losing that information.
So you still have a PIM domain.
Exactly.
Right. The PEs aren't part of the beer domain.
Yeah.
That's
Yes, of course. Yes.
So you still have a provider PIM domain that join is referencing.
Okay,
I mean, I can take this offline. We can go over a napkin and discuss this.
That seems to be the core of the work here, right? That you basically try to explain how you tie in whatever you're doing between the egress access and the egress PE,
right,
and the ingress PE into beer.
So
and
think
Forget about PE.
Yeah, there's still a like think of it that way. What you're achieving is you're removing the state, and you're removing a needs for duplications of traffic just because the size of the domain is so huge. So even if you're running it on a PE levels, and we would run a beer from PE1s at the tens of thousands of scale, okay, we all have hardware limitations. None of us will get to tens of thousands.
Yeah.
So by pushing it one level into the core, we can scale better without the need of a stack.
No sets or areas or anything. Yeah. All right. Or revving 10,000 hosts or 10,000 routers.
Yeah, again, I do apologize. This is not the latest version, but
It says V2. I swear it does.
I think I sent V3.
And actually, V3 doesn't have there's a V3 and it comes with an app.
All right,
Yeah.
let's roll. Let's roll. All right, next slide.
Yeah, next slide, please. One more.
All right.
So this is exactly what Andrew just explained. So what this will give us is in the core, it's going to be a clean core that you don't have any multicast states. You don't have any extra BGP running between the P1, P2, P4, because everything, all the signaling is being tunneled through the beer. And if this is not a completely broadcast domain, if it's truly a multicast domain, each one of those beer edge routers will have a limited multicast state, which will help the hardware and will actually help some of these providers. That's all I got. That's all I got.
Yeah, I mean, this reminds me a lot
Torlis?
of
Name.
Torlis, I think. And so 10 years ago, the RSVPTE point to multipoint, when they also had scale with the number of LSPs they could put in a tree, and they also backpulled the RSVPTE trees only to the egress P nodes. And I think then the only question was always, is the edge state that you have on these egress P nodes, is that, more, functionality than you would like to have on a P node, right? So I think you're trying to make the argument that the overall complexity of having, PIM on an egress side and BFER, that's very lightweight. So I think that's what
Exactly.
I think the major review point is what operators think about that, right?
Exactly.
Look at the author list, Torlis.
No, understood. Yeah. I'm just saying that it's not always all the authors that are on the draft. If they are, that's fine. But I'm just trying to understand.
All right, one more question.
Stigmanas. So if you forget about MVPNs, right, there's no PEs really, but you have certain routers, of course, that are at the edge of your beer domain. And in the draft, you say that, you say that how to basically figure out where to send the join, what the PBER is kind of out of scope.
Yeah.
And it seems, I have some idea how we could do it, but it seems that is the most tricky part of this, perhaps.
You're absolutely right. There are multiple ways of skinning that cat, depending on how the operator wants to go. If the operator, I'm just giving you an example. If the operator wants to make that P1 and P3 to be an ABR router, which summarizes the route, then the ABR router starts the route with its own loopback IP address. So that's one way of doing it. But definitely we are open to ideas here.
Yeah, I think it would be good to at least explore that a bit in future versions.
All right, thank you.
Just one more thing. I think it would be good to use the beer prefix as a source address for the PIM join. Basically, because the beer header is not necessarily available to the PIM implementation when it processes the join message.
Okay, we can talk about that.
Thanks for the comments. It's back to the doing where my exit points are. So we already get also some other comments. So we'll add this text, clean some stuff, rushed a little bit here. Sorry, guys. And we'll post you in the new versions. If there is something missing, please.
To the mic,
Guys.
Mike,
we can't hear you.
we can't.
Oh, I cannot hear. That's the first one somebody told me cannot hear me.
Yeah, I'll give you some more comments.
Okay. Yeah. Thanks.
Thank you.
Thank you.
All right. Next.
So basically the action item is the authors are encouraged to clean up the draft after all these comments and then stick you or the next guy on the list to actually go and look over the PIM. And you see, he already asked for the source address.
Perfect. Thank you very much. Catch up this time. You'll be fine. Just rough notes and concepts and names. You don't have to do word by word.
Yeah, I know, but even the acronyms, they are.
Welcome to Malta.
Beer is a beverage.
Beer. I can continue, but that's just.
I trust you.
Oh, cool.
Oh, yeah. Pierre, I know your work ethic, and you have not seen the crap minutes we've gotten in the past. So trust me, you're doing just fine. No, none of you. You've always given me great minutes, all of you. Yeah. Well, you get the arrow, but it won't. Oh, gotcha. You're gonna blind me. All right. So Babel first, right? You have an arrow? Laser dot?
But it's not flexible.
Cat's not chasing it? All right.
Can't.
We'll be fine.
Please page
Yeah.
which one? Okay. The first page is page up. Okay. Good afternoon. I'm Sandy Zhang from ZTE. This afternoon, my first presentation is for the update of BIER in Babel draft. Next. I think most of people in this meeting room are familiar with the BIER protocol. So I think I needn't read this page. Please, page. Let's see the brief introduction of Babel protocol. Like BGP, Babel is a distance vector routing protocol, and it can be used in wired and wireless mesh networks. And in the latest version of Babel protocol of RFC 6126 bits draft, sub-TLV has been defined to carry extension in BIER protocol, in Babel protocol. So BIER information can also be conveyed by this way. Next. It's a similar way to do this. The BIER information can be carried in Babel update message. And we use a new sub-TLV to define this. And because there is a mandatory bit in Babel protocol, so the mandatory bit of BIER sub-TLV should be set to 0. If a router cannot recognize the sub-TLV, the router can ignore its sub-TLV. And we can use Babel protocol to transfer the BIER information. So every node in the network can receive the BFR ID and the BFR prefix and the other information. And
so Sandy, I'll just in a minute, sense of time. I don't think we have a lot of Babel experts here, right? So we can go into the detailed one. I think conceptually we understand what the requirements are in an IGP. This is a new IGP.
Yeah.
So can you give us maybe feedback because you presented this in the Babel working group?
Yes, I presented in Babel
you got feedback in that. Well, let's cut to that because I don't think, do we have any Babel experts in the room right now? Yeah, we got one. Okay, all right, good. All right. Have you read and digested this draft?
I've read it.
Okay. Gotcha.
He's digesting right now.
All right. Were you in the working group, the beer working or the Babel working group for this?
Yes.
All right.
This is the man who invented Babel.
So let's see the format.
All right. So let's cut to the information. Still to solve. Okay, that's good.
Oh, okay, that's fine.
Yeah.
And the extension has been implemented in the source code of Yuli's team. So you can find the information through this link.
So
that's working.
Oh, gotcha. So you're trying to, how do you address non-beer speaking Babel routers in the network is what you're talking about there.
It's only control plane beer Babel
yeah.
extension. Yeah.
And there's an implementation?
Yeah, implementation.
Wow. Excellent.
So for my personal point of view, I'd like to do this draft here in this group because I think it has more relationship with beer.
So
but I respect AD's opinion, and I will follow the AD's follow decision.
So minimal context. Babel is now pretty much considered as strong candidate for the HomeNet protocol, and the HomeNet guys are still looking for a multicast solution. So there's opportunity to talk about beer within HomeNet.
Okay, Julius Krobacek, I'm the scribe in the Babel working group. And so just to give a quick, we are looking at that with a lot of interest. However, right now in Babel, we are focusing on the core specifications and trying to avoid spending too much time of extensions until the core specifications are done. So we're not adopting that yet. Okay, which doesn't mean we'll adopt it, but we're looking at it with a lot of interest. And we are excited about that.
Julius said before, he said, I must have done beer data plane. I think it's a bigger project. Yeah.
Right. Torlis, you had a question? Okay, so just what you referenced before is we've done the IGP work in here because those IGPs are fully cooked, right, for the most part. And we're just doing extensions to them. And then when we go to last call, which we've just done, we get feedback from those appropriate associated working groups as well. I think in talking to Aaliyah, if I just provide your words in this conversation, that's okay. Babel is still, like you said, you guys are busy. You're doing a lot of other work. So I think the beer stuff is fairly well cooked. What's not cooked is the Babel side of it. It's not as understood as like ISIS or OSPF is being cooked. So the suggestion was it may want to live there instead while you guys bake the rest of the solution. And then we stay on top of it for, make sure that the right beer information's in the signal.
Thomas Eckert. Is there randomly an MBOND working group chair here in the room? I was wondering if the HomeNet folks ever came to MBOND and asked what would be your recommendation for the best multicast solution in a HomeNet.
So
that's I think
that's
where it
actually
should
a great
start.
question, and I can jump on a soapbox and go on for hours because we used to have a multicast kind of steering working group, and that's gone. MBOND's kind of picked that up, but the mechanism within the IETF tends to be you have to publish stuff to get people to come, as opposed to gee, multicast is an interesting idea. Let's bolt it on later, and then not talking to the people who do it. So I think this is happening already here, Torlis, but let's not talk process and procedure so much.
No, but I'm just saying that it would be nice if basically multicast folks
you said that time-wise, man. Let's move. We know it would be nice. It didn't happen.
Yeah, Pierre Pfister. I went to MBON and PIM. They didn't care.
They didn't care about Torlis? That's not true. That's not true.
Excuse my chair.
Young lady at the mic.
Aaliyah Atlas. Yeah, so Babel is the place for this work to happen because there are aspects of the encodings that are different from OSPF and ISIS that are not as well understood in the broader community because beer depends on, say, advertising things which works well in link state, and obviously there are ways of doing it with BGP, but Babel's a distance vector, and so there are mechanisms to do it, but it's not a trivial dump in, everyone knows how to do this. So I want to make sure that the Babel expertise actually gets to look at it and be very comfortable with it. On the HomeNet piece, if you look at the HomeNet architecture, all that it says about multicast is PIM, and I am not aware of any other discussion, but I think personally this has some interesting promise.
Tim Chown, editor of the HomeNet architecture. There were some discussions about it, and I do remember things like discussing the scope. I'm pretty sure it was discussed here at one point very briefly, but people like Ted Lemon got involved with it as well. I think he was AD at the time, about certain guidance on scope and other things. And I think also Babel is the HomeNet routing protocol, isn't it, rather than a routing protocol?
Yeah.
Okay.
All right.
I don't want to open old wounds with anyone, but
yes. So we're tight
Okay.
on time, but I think this is an important question we want to address. What would be the proper procedure to make sure these working groups work together, not only just to get the beer specification correct, but to work with the broader multicast expert community within the IETF to give direction for HomeNet? Sure.
So the great thing about So the great thing about mailing lists is you can actually include more than one. From a process perspective, of course, things like adoption calls are very nice to include other working groups on so that they're aware that you're coming to a pivotal point. If you hit a point where you're like, we think this is, there's a good in this case, there's a good implementation. We think, here you can go take a look at it. Let us know concerns. Those are really good checkpoints to check in with the other working groups that are not paying as much attention. And of course, you could all come to Babel too.
And here's some old-fashioned observation. After all the procedures, a little bit of running code goes a long way these days.
Okay.
I have patents.
NBO3.
Okay. My second presentation is the analysis of use beer in NVO3 network. Let's see the left figure. The left figure is NVO3 generic reference model. There is already a working group document about multicast framework in NVO3 network. And the PIM and the beer is also be mentioned because they can also be used as IP multicast underlay technology. Let's see the right figure. Let's see the right figure. We can use the example topology of ML3 underlay network. We replace this part from the virtual L3 overlay network into leaf and spine topology, and it's general topology used in data center. And we know that if we use PIM as the multicast underlay, and the PIM must build a multicast tree in leaf and spine devices. So leaf and spine device all have their multicast flow state. And in case one of the source and the receiver leaf changed, the multicast state along the trees needs to be changed. And let's see beer technology. So the first one, I don't need to read it. Okay. Let's see the beer requirements. Every edge nodes include BFIR and BFER need to be assigned a unique BFR ID. And the edge nodes should exchange BFR ID and BFR prefix and the other information by IGP BGP extension. And the beer ingress nodes for a multicast flow encapsulates the multicast packet in a beer header, which destination is the BFR ID set of beer egress nodes. So when we do the study of using beer in NVO3 network, we found there may be two ways to achieve the goals. The first one is placing beer boundaries at leaf switches. And the second one is putting the beer boundary at NVE to achieve better efficiency. Next. Let's see the first method. The first method, leaf devices, we use the leaf devices as the edge beer nodes. So we know that every leaf devices will be assigned a unique BFR ID. And the leaf devices and spine devices exchange the IGP or BGP extension to build the beer forwarding plane. But NVE, the BOM flows want to send from NVE to leaf, and leaf must know the destination. Leaf's BMLD protocol must be used between NVE and leaf devices. So the multicast group information can be changed through this way. But the BOM flows must be mapping to one special group address. So after the exchange, the ME sends the BOM packet to leaf device. Leaf device will encapsulate the flow with beer headers, which the destination is leaf devices. And we know that from this method, we know that IGMP MRD is still needed to run between NVE and leaf devices. And the multicast group for tenants and the specific multicast application are still needed. And the third one is the BSL limitation. I think it's a general question. Let's see the second method. We use NVE as beer edge nodes. So every NVE will be assigned a unique BFID. And still, beer forwarding plane must be built from the IGP or BGP extension. And NVE can encapsulate the packet with the beer header straightly and forward it to leaf device. And the leaf device can forwarding the packet straightly to the spine network. So from this method, we know that we know in some situation, NVE cannot run BGP or BGP extension, and it cannot exchange the IGP or BGP information with the network devices. So the NVE's BFID and BFR prefix must be advertised by any other ways. And the second thing is still the BSL limitation. So we know that from this way, we don't need to run many much complicated protocol, and we can achieve a better efficiency. Any comments?
Comments? Has this been presented in NVO3?
No. I wanted to make a presentation in beer at first, and I want to know if it is make sense. Yeah.
So how does multi-homing work? Tony P, Juniper. So did you give thoughts to multi-homing, especially the previous model? That will be my only comment.
This?
Or you need some model for multi-homing. I mean, if someone sends a join, IGMP join over two interfaces to two leaves, then you need to resolve this somehow to not get duplicates.
We know that because the existed solution of multicast is use PIM between these. So
you have no PIM.
Method,
yeah, no, PIM resolves that. But if you just start to IGMP, how do you resolve multi-home?
Yeah. Because we must encapsulate the packet with some signal. Because leaf cannot know the destination and the ease information. So leaf devices must know the destination leaf devices information.
No, let's take it offline. We talk.
Yeah, because I've actually got a whole bunch of input on this as well, and I don't want to bury it too much. But if people are interested in this work in any way, let's take it to the list. Let's see if we can provide us some feedback and get an architecture if we want to take the NVO3. Thanks.
Okay.
Next
Thank you.
Who is next?
I think it's me.
It's that Torless guy.
Just a quick comment to this one,
Sure,
right? I
please.
think it's perfectly valid to present to NVO3 with respect to this is the value it gives. They don't have to understand how it works in detail. Just if they give the feedback that, yeah, the service that they get out of that would be interesting, but they can't figure out if it actually works, then basically that would be a lot more motivation for us to understand all this crazy NVO3 stuff, which I don't currently. So
I must clarify that this draft is under the discussion with my colleague that who works on data center. So he give much information to me. Yeah,
It's basically, if the working group says, hey, multicast would be nice, if these people think that beer could do it, that's fine, but we can't judge that it works. Please get that checked by then. We have the motivation to check it because so far,
I forgot to say beer has been mentioned in the multicast framework in MU3 working group.
So Aliyah Atlas, there is a multicast, right. So as Sandy just said, there is a NVO3 MCAST architecture framework draft, which is in my publication queue, which just went to PIM and MBOND for review. So, and got, for during the working group last call and such. And it would be very nice to have feedback. I'm certainly happy to have extra reviewers during IETF last call.
Yes. So just for the sake of minutes, Pierre, yeah, my requirement as a chair is to reach out to them and get that last call sent to the beer list as well.
The working group last call is done. It's in my queue.
Oh, oops. Okay.
But that doesn't, technical considerations are always, earlier is better.
Yes.
But that doesn't mean that if there's any issues, it's a bad thing. And there's always IETF last call to comment during. I'm happy to forward it along.
Okay. Thank you. Yeah, fine. We're fine. The man with no tour. Go ahead.
Yeah. Next slide. So basically, I wanted to bring back the BRTE drafts. We have a BRTE architecture draft and a BRTE FR draft. And so basically we had some, issues that made them expire both from the author's side, and then also I think early on when we were doing the first call for adoption, there was more things on the plate, and so we got the notion that.
So from chairs, I would say when this first came out, beer was getting off the ground, right? So we were focused on getting the general architecture in place. And there was some serious concerns that came from a particular contributor from the working group. So did you rev it to address those concerns?
That was done. That was done. But then basically we didn't review, we didn't renew the call for adoption, because then was also, we have so much things in last call, and the authors had issues, right?
Update us and let's see where we go.
Yeah, that was done. So what the 04 was actually, so I didn't do anything new on the BRTE stuff. That was fixed in before. But the last things that we got back was that the whole FRR story that we had was first, spin it out. We had done that last time. On this time around, the 02, we did respin and put the scope of the FRR completely, so that it hopefully better matched what the feedback was we got. Okay, next slide. So just quick summary here for people who haven't seen BRTE, right? So it's basically just like beer, except that the bits now can also indicate intermediate hops, not only BFERs, and that way you can steer traffic through the network along paths that you would like to do. And the trick of that is that you only look at the bits that are adjacent to your node, so that you can exactly only care about how you get it. You don't even need any IGP routing protocol or anything in BRTE, because the stuff gets steered purely by the bit mask. And we feel that, the hope is that the BRTE forwarding rules can easily be added to forwarding machinery. So if basically the industry is starting to look into the forwarding machinery, it would just be lovely to have an RFC, so that the chance is not missed to get that added into the next generations. There is a lot of work in the BRTE architecture draft to try to minimize the number of bits needed, because obviously when you want to indicate all the hops through the network, you need more bits. So that's the majority of the complexity, and that's all in the control plane and not in the forwarding plane. Next slide. Okay, so BRTE FRR. So basically now we did come up with a very complex solution to do it natively in BRTE, and basically we sorry, what's your time?
Oh, no, you got 2 minutes left.
Oh, okay. Right. So we basically went through the different options, right? The first one is live. Next slide. And that's basically this wonderful thing where you send a dual through the network, and obviously want to have engineered path to send things around, right? So that's basically an ideal use case for BRTE, that you can engineer the traffic. Next slide. You can also then simply reduce that complexity and sending only one copy at a time, do failover to the other one. And what actually helps you greatly there is the fact that in BIER and BIER-TE, you can indicate the receivers very quickly. So you can very quickly, without signaling changes, change the set of receivers, right? Then basically link protection, just use whatever link protection you have. That is nothing new. Next one. Node protection, that's obviously where existing mechanisms are really bad because you only have point-to-point backup tunnels. So you want to have something better than point-to-point backup tunnels for node protection. Next slide. So now basically how would you do node protection with BIER-TE? Two options, BIER-TE and BIER-TE NCAP. That's probably the most reasonable option. And then basically this native solution that we had invented, which is cool optimization, but it doesn't work in all cases. So that's basically the summary of the rewrite of the BIER-TE FR draft. Last slide. So there was research prototype implementations done by the co-authors and their students. P4, you can read up all on that. And so we're asking for working group adoption for BIER-TE architecture and the FR draft. And yeah, we would love to, see the chip vendors be confident that a working group review has been passed so that we basically, that this stuff works.
So for the sake of time, and just consider charter be damned with this question. Who thinks this would be work that we'd want to adopt and do here in the BIER working group? All right. Who thinks it doesn't belong in the IETF or doesn't belong here? All right. Good. So I'll address the charter next. We talked about this. All right. Questions. Improve recovery. That's it. Yeah, exactly. It's going to go to the list. It'll go to the list. Exactly. I just want to see where the room was on interest. Yes. Can I help you?
Yes, thank you. Sorry, Elias. The question I have is, who thinks if this has hardware impact, is this something that's going to stall, that where we need to hold off the architecture or the encapsulation? That's the key point. The charter we can work with, but the question is there enough enthusiasm for the delay in finalizing an implementation and so on?
So I'm dusting off some old brain cells here. Tortoise, we'll give you 2 seconds here to jump to the mic. From what I recall, the BIER fib doesn't change. It's how it's built, and we'd have to set it. It would be like a separate set. But it was a long time since I whiteboarded this stuff. It was napkins, I think.
So sorry, Alia, just to give me the concern again. Even if there is additional forwarding things to be done, I think it's up to the vendors to decide if they want to do it, right? We're not saying that they must do it in the same round or so, but if they have the opportunity, they look at it and whatever,
But if it changes the BIER architecture, it should be part of the BIER architecture draft, is her point.
And I don't necessarily think so. I think it's
extend.
an addition. It's an addition to it, and we could go through the use cases, for example, which might.
We have.
Right.
I know we have limited time.
Yeah.
And we need to talk about it on the list, and I need to look at the draft in more detail than looking at the most recent slides, which said want to get this in so people can fix their implementations now. But that's the concern.
Yeah, thanks for bringing this up. I would not delay the BIER architecture and stuff because
I agree.
Because this is an addition.
I agree.
Yes, I think so.
There are programmable hardwares that can deal with that.
Yes.
Other hardware.
Yeah, no, I also wouldn't want to hold up anything, and so.
Yeah. Well,
I think it's just really the working group getting through with this so that the implementers can check at it. Is it feasible in this hardware or not? I mean, why would I want to? I don't know how they built these things, how extensive they are.
EVPN. Oh, there it is. It is here. Thank you, Torres. Pierre, we're trying to talk as fast as we can. I hope that's helping.
So this work is about using BIER in EVPN network. We have co-authors, myself, Tony, Ali, and Jorge. Next slide. So for EVPN, you can have all kinds of provider or underlay tunnels, P2MP, ingress rating, all kinds of those things. And now we can also use BIER. And when we use the BIER for EVPN tunnel, it's actually very similar for the MVPN case. So in fact, we borrowed quite some text from the EVPN, MVPN, and beer MVPN drafts. So with EVPN, there are auto-discovery routes, in particular IMAP routes and some other SPNZ routes that define in that draft that announces what kind of tunnels to use for certain flows. That route carries a PTA, it's a PMZ tunnel attribute. That PTA basically identifies the tunnel that's used to, that is bound to that route. The PTA including the tunnel type, identifier, label, and flags. Next slide. Next slide, please. Okay, so when we use beer for MEVPN, the PTA, the fields will be encoded as following. The tunnel type will be set to beer. This is already defined for the beer MVPN. Tunnel ID, again, the same as MVPN. It includes a subdomain ID and the BFIR prefix address. Notice that this beer tunnel is considered as an aggregation tunnel, which means that no matter how many bridge domains you have, you only need one tunnel for it. And because of that, we need to carry a label in the case of MPLS infrastructure. That label is upstream assigned by the BFIR. This, in the simplest scenario, it identifies the bridge domain. I will not go into the other scenarios here because I don't have enough time. If you are using the VXLAN or MVGRE, then the label field of the PTA will be the VNI or VSI that is globally unique. Right now, we don't cover excuse me, GNIV. That could be added in the later version. And then the flex field, there are two bits could be used. One is the leaf information required bit. The other one is leaf information required per flow bit. I'll get to that later. Next slide. So for beer, the BFIR needs to find out which BFERs need to receive the traffic so that it can construct the bit string. How do we find that out? This procedure is called leaf tracking. If we are using inclusive tunnel, the EVP and IMAP routes, which is equivalent of the inclusive IPNZ route in the MVPN case, that can be used to track the PEs that need to receive the traffic. And also, there is this SMAP route that is defined in the IGMP MLD proxy drafts. That's basically for each PE to tell others, I need to receive traffic for a particular SG or star G. So that route can be used for leaf tracking purpose. Now, there are some other scenarios that we need to use SPNZ routes for that purpose, and that requires corresponding leaf AD routes that is triggered because of those two bits carried in that PTA. So the draft talks about that, the slides talk about that, but I'll skip it in the presentation now. Next slide. So now come to data plane. If the underlay uses the VXLAN or MVGRE, then excuse me, the packet, the payload is the Ethernet frame that comes from the CEs, and then you will have a MVGRE or VXLAN header, and then outside is the beer header. Notice that here we do not need the IP or UDP header anymore. For that, the beer headers protocol fields will need to specify a new type, two new types for the VXLAN or GRE. And when it comes to multi-homing, split horizon procedures for VXLAN or MVGRE is local bias based, and that still works because the BFR ID in the beer header identifies the BFIR. You can use that information to do the local biased split horizon procedure. Now, if the infrastructure is MPLS network, then beside the inner Ethernet frame, you may have ESI label for split horizon purpose, and then you have a label per BT. Here, the BT is per bridge table or a broadcast domain is the same thing. And in a more complicated situation, you can have a label specific for the PMZ. I'm not going to there. So notice that here it's possible that we have two upstream assigned labels when the traffic is coming from multi-home Ethernet segment. Next slide. Segmentation procedures. It's somewhat complicated. How much time do I have?
No, keep going.
Okay. All right. Segmentation, independent of beer, in an EVPN or MVPN network, segmentation could be used in the MPLS situations where maybe it's required or maybe it's desired to use different tunnel technology in different ASs or different areas. And it could be that in AS1 you use RCP P2MP tunnel, in AS2 in MLDP, or in another AS or area you use beer. And then when it comes to beer, there is another use case where you have a large EVPN or MVPN domain where you have many PE routers, and but you have your bitstring length is only 256. So you could send multiple copies using the multiple sets concept. Another way to address that problem is you divide that beer domain into smaller subdomains. So inside each subdomain, you only need to send one copy to the smaller set of the BFERs. Those BFERs could be EVPN PEs, or it could be at a segmentation point. And that the segmentation point will further replicate the traffic into the next beer domain or next MLDP domain. So that's the general concept of the segmentation. So to do that, the segmentation points will update the PTA field when it re-advertises those routes into the next one to specify a new tunnel type or new tunnel ID. That's the general concept of the segmentation. Next slide, please. Yeah. So here is an example. We have 5 PEs here. There are we have 2 subdomains. In the middle, there is an area border router. And we have 2 auto-discovery routes, with here we call them SPNZ routes, R1 and R2, advertised by PE1. Now, ABR received those 2 routes. It re-advertised that into the next subdomain. It's still R1 and R2, but in the it will update the PTA in these 2 routes. In those 2 routes, in the routes received by ABR, the PTA could specify that is subdomain 1 and BFIR is PE1, and the upstream allocated label is L1 for this particular flow, and L2 in the second route for different flow. So when ABR advertises into the next domain, notice that it will change the BFIR to ABR to itself and change the subdomain ID to S2. And more importantly, now the different labels are advertised. They're label 3 and label 4. Now the ABR will set up the forwarding path so that when it sees label 1, you will label switch to label 3. When it sees label 2, you will label switch to label 4. So now when the beer packet comes in, arriving on ABR from PE1, it does the decapsulation, beer header is removed, and it sees label 1, you will label switch to label 3, and then you will send into the next subdomain S2, putting onto a new beer header. The 2 subdomains are completely unrelated. The ABR does the stitching. Next slide, please. So next steps, we request working group comments. In fact,
let's roll. Who's read the draft?
things.
Go ahead.
This draft should have been presented in the best group as well, but I forgot to request it, and they also run out of time anyway. So
all right.
The comments should go to both working groups, and next time I'll try to present it in the best working group as well.
Excellent.
Yeah.
Thanks. All right, one more. Bear with me. Thank you, Jeffrey. So this is just status update. I kind of like the conversation at the end, but we're out of end, so it's just going to happen. Where am I? Right there. Done that. All right. We actually have something in the queue. Well done. And I think we have an open discuss right now that I'll just address it directly. It's operational considerations. So Lee and I talked about it a little bit. I've kind of worked on a little paragraph. It's not like we have to go into a complete operational architecture under the architecture draft. It's more like, what is operationally different about what we currently do versus what BIER offers, and just so people can read it and, I guess, expand their head a bit about what BIER does for their network. I mean, that's the best I can describe, because there will be operational documents coming out of this group that address that directly. Details that won't be in an architecture draft. All right. Your question? I saw a finger going up. So the rest of these, they've all gone last call. They've all been, I guess, well vetted with response, except for two. ISIS and the IDR extensions, those two have gotten no feedback at all on the list. So I'm going to kick the lists again for both of those just to get some feedback, and then we'll progress the other four. And Tony here is going to be looking for shepherds. So who here is looking to, shepherd's an opportunity to get your head into how the process works. It's not a big time consuming requirement of any kind. There's just a QA sheet. There's a whole list of questions, a draft that you go through to say, answer these questions with respect to this draft so that we understand that it's properly gone through the vetting process in the working group before we progress it.
Oh yeah, just to be clear, you also have to actually review the document.
Reviewing the document, to answer the questions, half the time you got to review the document. Half the questions you have to do. Others are like, did the list go through the work to the draft?
Right, but it is a really good way of seeing like sort of the IETF process through, particularly if you haven't had the joy yourself. And Joy's, yeah.
Joy.
And it's also a really helpful way of indicating the strong interest in the mailing list in the work, that there are people who are willing to volunteer to actually help with the process load and getting it through.
Excellent.
So the chairs can continue to push on the other things.
Yeah, thank you. So we'll put, I mean, if you guys are interested, right, what we want to do, grab us this week. Otherwise, we're going to offer the requested list and get some feedback there. Again, it's just jump in the middle of the sausage factory and see how things are chopped up. But it's a great way to learn and get engaged. Boom. Aaliyah, I'm sorry, I took your notes at lunch and then I didn't put them in this deck. But basically, what we're going to do is get the architecture draft through. Once we have something through, then the IEEE will address that rather than trying to get it cart and horse. In caps draft, I'm sorry.
Yeah, sorry. This is
draft.
Oh yeah, yeah. So what we need is the encapsulation draft. Tony sent me some fine text about what what the architecture is, the encapsulation is doing by preserving the common header format, and that's something I'll be able to put into the request for IEEE. Given how soon the MPLS encapsulation is happening, and given that I have not heard publicly or privately of anyone having a really strong need for the ether type being allocated more rapidly than we might expect from our very collegial relationship with IEEE, I'm happy to wait for the MPLS encapsulation to pass the IESG.
Which has just cleared last call, so it's going to be sent to you and Q.
Yeah, August is going to be busy.
I just heard you're looking for things to do, so I'm just trying to help out.
Your generosity is overwhelming.
I'm here for you. Okay, just going back to the charter again. We're out of time. Please bear with me. A couple things I want to address, as this is important. Our charter is specifically talks about this work being experimental. It also gives us some hurdles to jump over to make that migration. We learned in Chicago that we can go to RFC process, get a number as experimental, and if and when the group makes the justification to jump to standards, it happens without revving the dock. So that's a clean process. We also got great feedback from operators. They were more concerned about getting a number, an RFC, rather than the track that was on. So because the chicken and horse requirement is we need to get bits in the field, get some feedback. other than the bits in the field, there are 4 things to talk about. What's wrong with the current solutions? What's the advantage of the new solution? How does it impact hardware forwarding, and how does it impact the internet architecture? All of these things we've talked at length in groups and on the list. So we've talked about putting this draft together from the hands in Chicago. We'll get it out there from feedback, and it's probably going to sit there and stew for a bit until we get some field feedback, but it's the next thing we need to do. From there, we can recharter and talk about what's next work to do here. This isn't something new in the forwarding plane, right? We got IP, we got MPLS, now we have beer. If you think about that, and the use cases are just going, coming out now, I think we're scratching the surface. I think there may be a lot of work to do here going down the road. So think about that, and we'll take it to the list. One more thing. So Linda Wang from ZD has moved on to Australia. She's watching this video anywhere. So everyone just say, hi, Linda. Can you do that? Hi, Linda. All right. Thank you very much. Oh, blue sheets. Everyone sign blue sheets?
Yeah, I'll take it.
Hey, man. Oh, that's crazy. The phone forever. Yeah, good to meet you face to face. Welcome to IETF.